Hello students, and welcome back to another geometry video. You know what to do. Pause the video, try these problems in your notes, and then unpause it to do them with me. Okay, we are asked to classify the pair of numbered angles. We learned how to do this in the last video. So we have angle 1 and angle 5. Notice that I have two lines that are being cut by, what did we call this? What did we call this line right here? We called it a transversal. Transversal. So that line is a transversal. And when I have lines that are cut by a transversal, angles that are in corresponding positions or the same position, top left, we call them, we call them corresponding angles. So angle 1 and angle 5 are corresponding angles. Alrighty, new color. Angle 2 and angle 7. Well, let's see. They are on opposite sides of the transversal. One is on the right and one is on the left if you tilt your head. And notice that they are on the exterior of the two lines. So this means that they are alternate exterior angles. Alternate exterior angles. And lastly, we have angle 5 and angle 4. They're kind of squished in there a little bit, but they're also on alternate sides of the transversal. 4 is on the right, 5 is on the left, and they are on the interior of the two lines being cut by the transversal. So these are alternate interior angles. Ta-da! Thank you for reviewing yesterday with me. Now, let's move on to what we have for today. Today, we are looking at section 3.2, which is about parallel lines and transversals. So yesterday we talked about parallel lines and we talked about transversals, but not together. We didn't talk about them together. So today, we are bringing together parallel lines and transversals. So, our learning target is that you know how parallel lines affect angle pairs formed by transversals. So the angle pairs we talked about in the entry task, alternate interior angles, corresponding angles, how are those affected by parallel lines? So you should know that. That's what you should have learned by the end of this video. And what should you be able to do by the end of this video? Well, you should be able to use these properties, use this knowledge to solve problems. So let's jump right into it, shall we? First, we're going to do a tiny little review from section 1.6. Remember from section 1.6 that two adjacent angles are a linear pair when they share a vertex and they share a side. So angle 1 and angle 2 are a linear pair, and remember that that means that they are supplementary. What did supplementary mean? Well, they add up to 180 degrees. So angle 1 and angle 2 are a linear pair, and they add up to 180 degrees. So you need to remember that for this lesson. And don't forget what vertical angles are. Vertical angles are formed by two intersecting lines, and it's the angles opposite each other. Angle 4 and angle 5 are vertical angles. And notice we have V's here. Angle 4 makes a V, angle 5 makes a V, but they're opposite. They're the exact same V, just flipped over. So angle 4 and angle 5 are vertical angles, and angle 3 and angle 6 are vertical angles because they are opposite each other. And don't forget that vertical angles, you'll remember this from chapter 2, vertical angles are congruent. Vertical angles are congruent. So if angle 3 is 60 degrees, angle 6 is 60 degrees. So you need to remember both of these things for our lesson today and for future lessons. Hopefully you already remember them from chapter 1. But if you don't, nice little review of them. Okay, next, there are 4 very important theorems that we're going to talk about today, and all of them have to do with our special angle pairs from last lesson, so corresponding angles. Alternate interior, alternate exterior, and consecutive interior. We're going to have a theorem about each one of those. Let me make my pen a little bit bigger. There we go, that's better. So, what does this theorem say, the corresponding angles theorem? Well, it says if 2 parallel lines are cut by a transversal, then pairs of corresponding angles are congruent. So, this is important if I have parallel lines. So here we have P and Q with the red arrows. So if P is parallel to Q, then if the lines are parallel, then corresponding angles are congruent. Don't forget, the equal sign with a squiggle above it means congruent. So I'll write the word congruent, but I'll also put the symbol in parentheses afterwards. So today, 3.2, today we're talking about if the lines are parallel, then what happens? Tomorrow we're going to switch things up, so I want to be very clear that today we're saying if the lines are parallel. We are assuming that the lines are parallel. Then corresponding angles are congruent. So, if P and Q are parallel, that means corresponding angles such as 1 and 5 or 2 and 6, they are congruent. Corresponding angles are congruent if the lines are parallel. Okay. Similarly, for the alternate interior angles theorem, if 2 parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So again, if P is parallel to Q, then, so we're assuming that the lines are parallel. If the lines are parallel, then alternate interior angles are congruent. So if these lines are parallel, which they are, I can see that they are because of the red arrows. If P and Q are parallel, then alternate interior angles are congruent. So angle 3 and angle 6 are congruent. What did it mean for 2 angles to be congruent? They have the same measure. So if this is 70 degrees, if angle 3 is 70 degrees, then angle 6 is 70 degrees. And angle 4 and angle 5 are also alternate interior angles. So if angle 4 is 110 degrees, then 5 is also 110 degrees. If P and Q are parallel. All right, the next theorem, alternate exterior angles theorem. If 2 parallel lines are cut by a transversal, I hope you're seeing a pattern here. If 2 parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. So the pattern is that all of these theorems are starting with the same sentence. All of these theorems start with if two parallel lines are cut by a transversal. So today is all about if the lines are parallel. All of our theorems today are starting with this exact same sentence. If two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. So then, alternate exterior angles are congruent. And if we look at this, so alternate exterior angles, that means I'm outside of the two lines and I'm on opposite sides of the transversal. So, like angle 1 and angle 8. And just look at them. Look at them. Angle, whoa, zoomed in a little bit closer than I wanted to. Angle 1 is obtuse, right? It's an obtuse angle. And angle 8 is also an obtuse angle. They look the same. They look congruent. If these lines are parallel, angle 1 and angle 8 look congruent. And they are. It's not always the case that two angles that look congruent are congruent, but in this case, if I have parallel lines, angle 1 and angle 8 are congruent. Okay. Alright, next, moving on. Our last theorem for today, before we jump into our examples, is the consecutive interior angles theorem. And it starts, if two parallel lines are cut by a transversal, right? Same thing we've been doing. If P and Q are parallel, then the pairs of consecutive interior angles are supplementary. So this is a little different. All the theorems beforehand were saying congruent. Look at that, congruent, congruent, congruent. So why is it that consecutive interior angles are supplementary? Let's take a closer look. Consecutive means that they come one right after the other, and interior means that they're in between the two lines. So 3 and 5 are consecutive interior angles. And look at this. Angle 3 is acute, very clearly acute. And angle 5 is obtuse, right? It is bigger than 90 degrees. So, acute, obtuse. Is it possible for an acute angle to be congruent to an obtuse angle? Something bigger than 90 degrees is congruent to something smaller than 90 degrees? No. No, these cannot be congruent. It's not possible for them to be congruent. But remember that my alternate interior angles are congruent. So 4 and 5 are the same. And you can see 3 and 4 make a linear pair. 3 and 4 are supplementary. But 4 and 5 are the same. So if 3 and 4 are supplementary, 3 and 5 should be supplementary. And they are. 3 and 5 are supplementary. So, if P is parallel to Q, then consecutive interior angles are supplementary. Supplementary. So that means that if 3 is 60 degrees, 5 needs to be, must be 120 degrees. Because they must add up to 180. They must be supplementary. Means that they add to 180. Okay, wonderful. Those are all the theorems we're going to talk about today. Now, we just need to jump in to our examples. Our first example says, the measures of 3 of the numbered angles is 120 degrees. Identify the angles and explain your reasoning. Okay, so 3 of these angles are 120 degrees. Which ones, though? Which ones are 120 degrees? Now, what you could do is you could say, angle 2 is acute. It's obviously not 120 degrees. Angle 4 is obtuse, so maybe it's 120 degrees. 3 is acute, so no. 6 is acute, so no. 7 is acute, so no. And hey, look at that. That leaves us with 3 obtuse angles. So that leaves us with our 3 obtuse angles. Our 3 angles that equal 120 degrees. But you need to be more specific. That's good intuition for you to think like that. That's very good intuition. But we need to go a step further. And the step further is, let me look at these one by one. I'll color code. Angle 4. Angle 4 is a vertical angle with the 120 degree angle, right? 2 intersecting lines right here, and they are on opposite sides. So let's call this, whoops, I want to leave my scratch marks over the 3 and 4. Let's call this angle 1, the one that's 120 degrees. Angle 1 and angle 4 are vertical angles. Vertical angles. So, angle 4 is equal to 120 degrees. Because vertical angles are congruent. And maybe we can write that too. Because vertical angles are congruent. Okay, next, we'll continue our color coding. So we looked at angle 4. Now, let's look at angle 5. Oops, somehow my scribble over 7 disappeared. Let's look at angle 5. Top left, top left. They are in the same position. So what type of angles are these? Corresponding. Angle 1 and angle 5 are corresponding angles. And, look at this. These lines are not congruent. These lines are parallel. These lines are parallel. So, because, we'll say, so, because the lines are parallel, corresponding angles are congruent. So angle 5 is equal to 120 degrees because the lines are parallel, therefore corresponding angles are congruent. All right. And lastly, angle 8. Well, look at this. Angle 1 and angle 8 are on opposite sides of the transversal, and they're on the outside of the 2 lines. So, angle 1 and angle 8 are alternate exterior angles. So, because the lines are parallel, alternate, let's abbreviate, alternate exterior angles. We'll use that abbreviation. Alternate exterior angles are congruent. So angle 8 equals 120 degrees. So we identified the angles and we explained our reasoning. That means that we're done. Let's check our answers. By the alternate exterior angles theorem, measure of angle 8 is 120. Oh, they gave a little bit different of answers than us. 5 and 8 are vertical angles. So the vertical angles congruence theorem says that the measure of angle 5 is 120. And 5 and 4 are alternate interior angles. So they gave a little bit different of a reason than us. But hey, our reasoning was just as sound. We used logic and reasoning. We got the same conclusion, and just because our reasoning was a little bit different, as long as our reasoning is solid, we're right. So just because we have a little bit different of answers doesn't mean that we're wrong. They drew the same conclusions as us. 4, 5, and 8 are 120 degrees. So yay, yay. Okay, example 2, using parallel lines. We are asked to find the value of x. So here we have x plus 5. So this is what I'm trying to find. Okay. And what else are we given? We're given that this is 115. They put a 4 here. And aha, A and B are parallel. Ooh, wait a minute. Remember, if the lines are parallel, then I know a lot of things. Corresponding angles are congruent, consecutive interior angles are supplementary. I know a lot of things if these lines are parallel. So, what do we know? Well, 115 and this angle pair right here, that's not an angle pair. That's not corresponding, that's not alternate interior, that's nothing. So we can't use those two. But these two, look at this, these two are vertical angles, right? 2 lines, and they're on opposite sides of those 2 lines. So angle 4 is equal to 115 degrees by the vertical angles theorem. And look at this, 4 and x plus 5, these are consecutive interior. They're on the same side of the transversal, and they're in between the 2 lines. So because these lines are parallel, we know that angle 4 plus x plus 5 equals 180 degrees. And we know that angle 4 is 115 degrees. So we have 115 degrees plus x plus 5 degrees is 180. So x plus 120 equals 180 minus 120 from both sides, and we get x is 60. X is 60. Beautiful. And we can check our answer. Here, I'll do this in a different color, but we can check our answer. If I plug this in, I get 65 for this angle. And 4 was 115. 65 plus 115. This better be 180. Oh, and it is. It is. So when we plug in x, we get 65, and 65 plus 115 is 180. So they needed to be supplementary, and they are supplementary. So yay. Yay for checking answers. Let's check it again. The haha did the same thing as us. Consecutive interior angles theorem. And vertical angles, they did the same thing as us. And look at that, they checked. They checked just like us. Yay. Yay. Okay. We're going to do an example very similar to the one that we just did. Make sure that we understand what's going on. So, find the value of x. They tell us that these lines are parallel, which means corresponding angles are congruent, alternate interior angles are congruent. It means a lot of things. So yay for lines being parallel. Now look at this. Angle 1 and 7x plus 9. These are, let's see, alternate exterior. Alternate sides of the transversal and outside the two parallel lines. So angle 1, the measure of angle 1 equals 7x plus 9. Because, well, here, I'll just say, because they are alternate exterior angles. Can we figure out what the measure of angle 1 is? Because if I can figure out what the measure of angle 1 is, I can solve this equation. So, is there a way for me to figure out what measure of angle 1 is? Let me get a different color here. Let's see. The measure of angle 1. Oh, wait a minute. Look at 1 and 36. They make a linear pair, right? They share a vertex and they share a side. So that means that angle 1 plus 136, excuse me, the measure of angle 1 plus 136 needs to equal 180. So, minus 136. That means that the measure of angle 1 is 44? I'm going to double check that. Minus 136. Yes, 44. So the measure of angle 1 is 44. Beautiful! Now I know what the measure of angle 1 is. So 44 equals 7x plus 9. Minus 9 is 35? Yes. 35 equals 7x. Divide by 7 on both sides. And we get that x is 5. We can check by plugging 5 back in here. 7 times 5 is 35 plus 9. So this should be 44. And is that equal to the measure of angle 1? Yes. Yes, it is. Beautiful. Beautiful. See if we were right? And then 44, substitute 44 because the linear pair postulate. Ah, and they even checked just like we did. Yay. Yay. We were right. Okay, that's all I have for you today. So, if you have questions, please ask them. Remember, questions are good. Questions are very good. These are problems you can do to practice the skills learned in this video, but remember they might not be the same as your homework. So check with your teacher what your homework is. But if you're just watching this for fun, you can do these examples to practice what you have learned. And of course, let's end with a launch. This launch comes from Mahatma Gandhi, and they say, "Be the change that you wish to see in the world." Now, you've probably heard this before. Be the change you wish to see in the world. And what this means is if you want the world to change, man, I really wish that people were less entitled. Man, I really wish that people were less rude. I really wish. Whatever it is that you wish, start with you. Start with you. If you wish people were less rude, don't be rude yourself. And then, hey, the world is a little less rude because you are less rude. If you want people to be less entitled, you be less entitled. And maybe people will start living by your example. Or people will start seeing your example and live by it too. So be the change that you wish to see in the world. That is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day. And thanks for being here. Thanks for watching. Bye.